Hello everyone, welcome to the next video, and this video explains us in this video I'll try to discuss what is acceleration. In the least number of words possible, सबसे कम शब्दों में अगर समझाएं, so acceleration A is rate of change of velocity. Rate of change of velocity, or you can use another set of words, change of velocity with respect to time. Now there are two types of acceleration as there are two types of velocities. So there are two types of acceleration as there are two types of velocities. There is an average acceleration and there is an instantaneous acceleration. So this is average and this is instantaneous. But right now we want to discuss the concept of acceleration. We are not interested in discussing average and instantaneous to begin with. We first want to discuss the concept of acceleration and what does acceleration mean to us in a general sense of terms. So let's say that I have a particle. It's somewhere here at t equals to 2 seconds, or not 2 seconds exactly, at t equals to 0 seconds, and it is moving with 2 meters per second. Now after some time, let's say at t equals to 3 seconds, its velocity is 8 meters per second. Now the average acceleration that you are going to calculate in this, and we are just calculating average acceleration right now, the average acceleration that you're going to calculate here is final velocity minus initial velocity divided by time, or in simple terms, an average acceleration can be written as change in velocity by time. So change means final minus initial, and in our case here the average acceleration becomes final velocity minus initial velocity divided by time. So final velocity is 8, initial velocity is 2, divided by time, that is 3, and 6 by 3, that is equals to 2 meters per second squared. So we call it meter per second squared, or we also call it meter per second per second. So the second one is more fun to say, per second per second, but you can say it both ways. You can say meter per second squared or meter per second per second. Now in a second case, let me call this as case 1. In a second case, the particle that I am discussing at t equals to 0, the particle was moving at 9 meters per second, and at t equals to 2 seconds, the particle is moving with 3 meters per second. So this is a second case where we can see that the speed of the particle is actually decreasing. The speed of the particle is decreasing. So if you want to find out the average acceleration in this case, it is going to be equals to, again same principle, final velocity minus initial velocity divided by time. So 3 minus 9 divided by 2, so minus 6 upon 2, and that is equals to minus 3 meters per second. So the negative sign tells us that acceleration is backwards, or in other words we can say that the acceleration opposes the velocity. Although it's not a very accurate statement, but it is used a lot of time. Acceleration opposes the velocity. So the second statement, I'm warning you, the second statement is not very accurate. Up till class 9, 10, 10, it is good enough, and teachers, all of us tell the students that now negative acceleration means that acceleration is opposing the velocity, but that is not a very accurate statement to make. A negative sign of acceleration simply means that the acceleration is in negative direction or backwards. So minus 3 meter per second. So this is, and this is also called as, sometimes this is also called as retardation. Now retardation is another name for acceleration where the speed is decreasing. Retardation is acceleration when speed is decreasing. Acceleration with decreasing speed. So that would be one way to write it. Retardation is acceleration with decreasing speed. But in acceleration, we can have increasing speed, as you have seen in the first case. Let me come back to the first case. As you have seen in the first case, okay, what's happening? So as you have seen in the first case, your speed is increasing. So that is also acceleration. And the second case, you have seen that your speed is decreasing, and that is also acceleration. There is also a third type of acceleration. Let me clear the page for this. There is also a third type of acceleration. Let's say the particle at t equals to 0 was moving with 2 meter per second. But after some time in its motion, the particle changed its direction, and now it is moving with the same speed but in a different direction. Let's say along y-axis. I can draw the axis if you want. So this is x-axis and this is y-axis. So particle was initially moving along x-axis with 2 meter per second, and the particle here is moving along y-axis with 2 meter per second, and let's say this is t equals to 2 seconds. So now what is the acceleration over here? So you have to understand that acceleration also happens when there is a change in direction of the velocity. So acceleration is also change in direction of velocity. So the first two cases were key acceleration was change in magnitude of velocity. Either the velocity was increasing or it was decreasing. But here the acceleration is change in direction of the velocity. And since the direction has changed, we are not going to simply use plus or minus sign over here. Since there are two directions, we are going to use I cap and j cap. Whenever there are two or more than two directions, if there is a three direction, you will have to use k cap. So if there are more directions, more than one directions, you'll have to use I cap, j cap and k cap, and these are what we call as unit vectors. So this is important, unit vectors. So acceleration is going to be equals to final velocity minus initial velocity. It's funny that you see I'm using same formula every time. The formula for average acceleration does not change, but the way to represent it, so the final velocity, this final velocity can be written as 2j cap because it is along y-axis, and initial velocity would be written as 2I cap. So it is because it was along x-axis, as you can see here, and divided by the time, that was 2 seconds. So we can cancel out all the 2's and we will have j cap minus I cap meter per second square. Now what I can do is this: I can actually find the magnitude of this acceleration, the value of this acceleration, and that would be root under 1 square plus 1 square, or 2 root 2 meter per second square. So there is something about acceleration that I wanted to conclude. जो मैं आपको बताना चाहता हूँ वो क्या है, वो ये है कि acceleration is change in velocity divided by time. Now that change in velocity could be due to change in magnitude, or change in direction, or both. It could be both ways. Magnitude could also be changing and direction could also be changing simultaneously at the same point of time. So let's see how that could work out. I'll take up an example here. Let's say a particle starts from here, from the origin, and at t equals to 0, of course, and its velocity is 10 meter per second, making an angle of 37 degrees. Now it takes up a path. The particle takes up some path. Okay, it takes up some path, and the path is not necessarily straight. It could be curved or something, maybe like this. And its velocity at t equals to 4 seconds maybe is 20 meter per second, but the direction has also changed and it is making an angle of 53 degrees with the x-axis now. So the final velocity, this is final and this is initial. You can see the direction has changed because initial velocity was making 37 degrees with the x-axis, and the final velocity is making an angle of 53 degrees with the x-axis. So this is also x-axis because these two lines are parallel. So how do we find out the average acceleration? So to find out the average acceleration, we need to specify what is v final and what's v initial. So v final is 20 cos 53. The way to resolve it is cos 53 I cap plus sin 53 j cap. So cos 53, I don't know if you know this, but in case you don't know, I want you to write it down and remember it because it is generally used in IIT JEE exams and they don't give you the values. So cos 53 is given as 3 by 5 I cap, and sin 53 is 4 by 5 and j cap. So if you multiply this with 20, you will get 12 I cap plus 16 j cap. I think that would be the final velocity. Initial velocity is going to be, what is the initial velocity going to be? So 10 cos 37 degrees I cap plus sin 37 degrees j cap. Same principle applied. So we can write it as 10 cos 37 is 4 by 5 I cap, sin 37 is 3 by 5 j cap. So it would be 8 I cap plus 6 j cap, I guess. Yes, that would be correct. Now the average acceleration, I can draw a demarcation line. I just don't want to confuse you here. So average acceleration would be final velocity minus initial velocity divided by time, and time is 4 seconds. You can see it from the problem, 4 seconds. So final velocity is going to be 12 I cap plus 16 j cap minus 8 I cap plus 6 j cap. So I'll subtract these two things directly. So the way to subtract it directly is simply this, that you subtract I from I. So that is 12 minus 8, that would be 4 I cap, and 16 minus 6, and that would be 10 j cap divided by 4. So I can actually simplify it. It would be I plus 2.5 j cap meter per second squared, and this is your average acceleration. Now as you can see excuse me, as you can see that this acceleration happened due to both things happening simultaneously. That is, the magnitude has also changed and the direction has also changed. So change in magnitude as well as change in direction of velocity. Now let us discuss the second type of acceleration that we know of. The second type of acceleration is the instantaneous acceleration. Instantaneous acceleration, as the name suggests, would be small change in velocity by small change in time. Instantaneous acceleration would be acceleration at an instant, and as we all know that an instant is a very small part of time. It's a very small fraction of time, and it doesn't matter how small. The smaller you take, the better. So if it is 1 millisecond, it is okay. If it is one microsecond, it is good. If it is 1 nanosecond, it's even better. So the proper definition of instant is not defined. The smaller you take, the better. That is the idea. The smaller you take, the better. So that is why we say that dt is tending to 0, and the closer it is to 0, the better it is going to be in terms of your giving the instantaneous acceleration. So how do we find the instantaneous acceleration? So let's say in one dimension, in one dimension, all instantaneous cases I am discussing in one dimension. All instantaneous cases I am discussing in one dimension only. In two dimensions, that is a separate topic, and we shall take it in a different chapter. Right now we are discussing instantaneous in one dimension only. So let's see the velocity of a particle, or let's not start from the velocity. The position of a particle is given as the position of a particle is given as 2t cube, let's say. Now first, if you want to find out the instantaneous acceleration, the first thing to do is find the instantaneous velocity. So the instantaneous velocity is going to be equals to dx by dt, and that would be equals to 2 times 3 times t to the power of 3 minus 1. So that will be 6t squared. So that is your instantaneous velocity. I'm telling you again, this is instantaneous velocity because it is the rate of change of position. Now if you want to find out instantaneous acceleration, the way to do it is simply find out dv by dt, and that is going to be equals to 6 into 2 into t to the power of 2 minus 1, and that is going to be equals to 12t. So this is your instantaneous acceleration. This unit is meter per second if everything is in SI units, and this unit is meter per second squared. So this is your instantaneous acceleration. So instantaneous acceleration if you want to find out instantaneous acceleration at, let's say, t equals to 1 second, so the instantaneous acceleration at 1 second is equals to 12 meter per second square, or instantaneous acceleration at 2 seconds will be equals to 24 meter per second square. Why 24? Very simple, we are going to use t equals to 2 seconds over here, and 12 times 2 is 24. So as you can see, your instantaneous acceleration is increasing. So this is how we find your instantaneous acceleration. Now there is one small confusion that students generally tend to land up. एक ऐसी confusion है जो कि students को अक्सर हो जाती है, और वो क्या है वो मैं यहाँ पे discuss करना चाहता हूँ. So let's say the position is given as what was the last position? I'll rather use the same one. Why to change it? The last position was x equals to 2t cubed, right? This was your position. And someone asks you find the average acceleration between t equals to 0 and t equals to 2 seconds. And the second acceleration, a second question is find the acceleration between, not between, if you want to find instantaneous acceleration, there will be just one instant of time. So find the instantaneous acceleration at t equals to 2 seconds. So this is the main difference between the two things I want you to understand. कि अगर आपको एवरेज एक्सेलरेशन दिया जाएगा तो आपको हमेशा एक टाइम इंटरवल प्रोवाइडेड होगा. सो इफ यू हैव गॉट टू फाइंड द एवरेज एक्सेलरेशन, देयर विल बी अ टाइम इंटरवल. So t equals to 0 to t equals to 2, or t equals to 0 to t equals to 5, or t equals to 1 to t equals to 6. So any time interval, but there will be a time interval. But if someone is asking you an instantaneous acceleration, it will not be a time interval, it will just be a moment of time. So how do we find these two things? So the job of finding these two things starts with finding instantaneous velocity. It does not matter whether you want to find average acceleration or instantaneous acceleration, you will always need instantaneous velocity. So the main confusion is you cannot, this is the resolution I'm giving, this is not the confusion, this is the resolution. You cannot find average acceleration from average velocity. So this is very important. Students do it a lot of times and they do it wrong, and then they are worried कि क्यों गड़बड़ी हो रही है. You cannot find average acceleration from average velocity. In order to find average acceleration, you also need instantaneous velocity. So let's see how that works out. So instantaneous velocity is 6t square. I have already done the differentiation, so I'm not doing it again. Now I want to find average acceleration between 0 to 2 seconds. So what am I going to do? We are going to find the velocity at 2. We are going to subtract from the velocity at 0 and we are going to divide by time. So 2 seconds, the velocity is going to be 24 minus 0 divided by 2, and that is 12 meter per second square. Okay. Now, if we want to find the instantaneous acceleration, all we have to do is differentiate the instantaneous velocity, and we have already done that. So 12t, and at t equals to 2 seconds, your instantaneous acceleration is actually 12 into 2, that is 24 meter per second square. So I want you to study this last example very carefully, pause and ponder it if you have to, because you have to understand that you cannot find, or we cannot find, average acceleration from average velocity. No, that would be a big mistake. It is wrong. Whenever we are going to find average acceleration or even instantaneous acceleration, we will always need instantaneous velocity. So this is very important, very crucial to understand the main difference between average acceleration and instantaneous acceleration. So I think we are done with acceleration. That is acceleration for you. From the next lecture on, we will discuss some other things regarding acceleration, constant acceleration, motion under gravity, and all those things. But that's all for acceleration. Thank you very much. I'll meet you in the next lecture. Okay.